Hello friends, welcome to the second video on the topic Machine Learning for Data Science. I am Shomir Roy, Professor of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, NITER, Kolkata. In the first part of this lesson, we discussed the basic concepts of machine learning. In this second part, we will go into further details of the topic. After successful completion of these two videos, you will be able to first explain the basic concepts of machine learning in the context of data science. Second, undertake applications of machine learning in educational scenario. Let us start with artificial neural networks, in short ANN. ANN or artificial neural network is a computational paradigm which is inspired by the structure and functionality of human brain. An ANN consists of a network of numerous processing elements called artificial neurons. The individual artificial neurons are capable of performing some elementary operations similar to that of a biological neuron. Usually, the function of an individual artificial neuron consists of receiving data from the neighbors, summing them up, and based on some criteria, send some output to the neurons of the next stage. However, if the neuron does not fire, there is no output. Such simple operation, when carried out by a structured network of large number of neurons, is capable of performing certain complex tasks such as classification and clustering. Moreover, the most important characteristic of ANN is their capacity to learn. ANNs are the only man-made structure that can be trained to perform a task. This unique characteristics has made ANNs highly effective in solving certain problems relating to classification and clustering. In recent past, machine learning, in short ML, and deep learning DL has emerged as important problem-solving methodologies. ML and DL are based on the underlying ANN structure. Deep learning. Deep learning, that is DL, refers to certain machine learning techniques that enables the computer to extract features automatically from huge data using complex artificial neural networks with very large number of neurons arranged in many layers, usually supported by powerful hardware platforms such as graphical processing units, GPUs. In short, deep learning tries to mimic the human ability to learn by examples. In deep learning, the underlying ANN model learns to carry out classification from images, text, or sound. Such ANN models are usually trained with the help of a large collection of labeled data. In fact, deep learning ANNs have the capacity to learn features directly from the data without the need for manual feature extraction. Moreover, DL performs end-to-end learning, that is, given the raw data and a task such as classification, the DNN automatically learns how to do this task. Again, DL scale with data in the sense that more and more data improves the accuracy of the model. In contrast, ML that is machine learning, saturates at a certain level. The emergence of DL in contemporary scenario has been fueled by two recent phenomena: creation and availability of large amount of labeled data, and development of powerful hardware platforms such as high performance GPUs with parallel architecture. When these are combined with cloud computing or clusters, we can achieve significantly reduced training time, say from weeks to hours or even less. The underlying architecture of deep learning is a so-called multi-layer feed-forward artificial neural network. Such a network consists of several layers of neural units. The first layer, known as the input layer, is used to feed the input pattern to the network. This input pattern is processed by the subsequent layers called the hidden layers until it arrives at the output layer, the last layer of the network. For ordinary machine learning, such ANNs contains 2 to 3 hidden layers. In case of deep learning, hundreds of such hidden layers are employed. A frequently used DL network is the convolutional neural net, CNN, or ConvNet. Convolution neural network outperforms other neural networks in handling image, speech, or audio data. CNNs are basically feed-forward neural networks having 3 types of layers, namely the convolutional layer, the pooling layer, and the fully connected or FC layer. The convolutional layer comes first, followed by additional convolutional layers or pooling layers. The fully connected layer is the final layer. Convolutional layer. The convolutional layer requires a filter, a feature map for the functioning. The filter acts as a feature detector which moves across the image for the purpose of identifying the presence of the feature. This is the so-called convolutional process. Then comes the pooling layer. Like the convolutional layer, in pooling layer 2, a filter sweeps the entire input, but unlike the convolutional layer, the pooling layer filter do not have any weight. Rather, the filter applies an aggregation function such as maximum, max pooling, or average pooling. Pooling layer causes loss of information. However, it eliminates unnecessary complexity and provides enhanced efficiency. Moreover, this layer helps to reduce the risk of overfitting. Now comes the last, that is fully connected layer. Here the output layer is fully connected to the previous layers, such as, that is, each node of the output layer is directly connected to each node in the previous layer. This layer performs the task of classification, which is based on the feature extracted by the previous layers of the CNN as well as the filters used. As we go from the convolutional layer towards the fully connected layer, the CNN gradually increases in its complexity. While initial layers are capable to extract simple features such as colors and edges, subsequent layers recognize more complex elements until the CNN eventually identifies large object, the target object. Now we come to regression analysis. Regression analysis is a statistical method to find the relation between variables as well as to predict the value of a variable, that is a dependent variable, with the help of other variable, that is the independent variable. Regression analysis can be divided into 2 broad categories: simple regression and multiple regression. Simple regression considers a quantitative or independent variable x to predict another quantitative and dependent variable y. The typical formulation of simple linear regression is given by the equation y is equal to beta naught plus beta 1 x plus epsilon, where x is the independent variable, y is the dependent or response variable, beta naught is the population y intercept, beta 1 is the population slope, and epsilon is the random error. Multiple regression employs more than one quantitative independent variables such as x1, x2 up to xk to predict a quantitative and dependent variable y. Further, multiple regression can be either linear or nonlinear. A linear multiple regression has the mathematical form of y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus etc. etc. until we come to beta k xk plus epsilon. There are various kinds of nonlinear regression such as polynomial, logistic, square root, reciprocal, exponential, etc. While linear regression is defined on continuous dependent variable, logistic regression is suitable to predict a categorical dependent variable. The mathematical formula for logistic regression analysis is given as log of y by 1 minus y is equal to beta naught plus beta 1 x1 plus beta 2 x2 dot 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 until we come to beta k xk. The adjacent figures shows the form of a logistic regression with respect to family income versus whether the family have an AC or not. Numerous data analytical tools are available in the market. Examples of such tools are Excel, R, Python, Apache Spark, Tableau, etc. Please go through the e-content of this unit for further details and a few case studies too. So my friends, in this lesson we have learnt about artificial neural networks, deep learning, convolutional neural nets, regression analysis, and so on so forth in the context of machine learning for data science. This was the second and the last video of the unit of learning. Hope you have pleasant learning experience. Please go through the e-material of this unit for further details. Thank you very much. See you again.